So homework 28 starts off with odd and even functions. If I just take the most basic even function and I have the graph of x squared, once I have the right pen, that's supposed to save, but it doesn't. If I do the graph of x squared, it looks something sort of like this. They're going to tell you that the graph of an even function is reflective across your y-axis. So if you folded it right along the y-axis and touch each other on both sides. If I do an odd function like x cubed, it looks something sort of like this. They tell you that if you fold it across the y-axis and then the x-axis, then it's going to touch each other. So it always ends up kind of being diagonally across your the origin of your graph there. So when you look at your graph, if you can split it in half across the y-axis, it's going to be an even function. If it's diagonally across and you can flip it one way and then the next way, then it's an odd function. So this one, if I divide it right in half there, even function, right? This one, if I cut it right across the y-axis, that didn't split it right in half, right? It's not opposite on both sides. That's going to be neither even nor odd because it's not diagonally across from each other either. When I'm checking an equation that's even or odd, one easy check, if you don't have parentheses, square roots, absolute values, any weird things in there, is just to look at the exponents. If the exponents are all even, it's an even function. If the exponents are all odd, it's an odd function. 0 counts as an even number, 0, 2, 4. So 4 to x to the 0 power, that's going to end up being an even function. However, if I have absolute values or square roots or some other weird thing in there, I can do a test to check if it's an even or odd function by using opposite values. Usually I use 3 and -3 because sometimes 2 and 1 you end up with incorrect answers because of 2 times 2 being the same thing as 2 squared. So I use 3 and -3. So what you do is you put 3 in for the x's and -3 in for your x's. If you get the exact same answer, it's even. If you get opposite numbers, it's odd. And if you get 2 numbers that have nothing in common, it's obviously an either. So just for fun, if I check this one, 4 times 3 to the 4th minus 2 times 3 squared minus 4. If you grab your calculator and punch that in, what do you get for that number? I think it's a little bigger than that. 302? Sounds about right. Now if you do the same thing but use -3 in for your x's, 4 times -3 to the 4th minus 2 times -3 squared minus 4. You get the same exact number. So that's an indication that, yep, we already knew it was even, but for sure that it is an even function because I get the same answer whether I do 3 or -3. Now this one, if I look at it, obviously I can see the exponents are 3 and 5. I know it's an odd function. But same thing, we could do the test if I do -2 times 3 cubed plus 4 times 3 to the 5th. Go ahead and punch that into your calculator. -2 times 3 cubed plus 4 times 3 to the 5th.
918.
918? And then if we put a negative 3 in there instead of a positive 3, whoops, I better put the 2 that's supposed to be there. Negative 2 times negative 3 cubed plus 4 times negative 3 to the 5th.
Negative 956.
Whoops, that didn't turn out right. Let's try it again. One of those must not be the right number then. Negative 2 times negative 3 cubed. Oops, if I have the right thing in there. Plus 4 times negative 3 to the 5th. Try that second one again. That's what it's supposed to be, negative 918. So when you have an odd function, when you use opposite values, you should end up with opposite answers. So if you test evens, should come up with the same number. Odd, you should come up with opposite numbers. But the easiest thing to do is just look at the exponents, as long as you don't have any parentheses or square roots or anything weird in there. So number 2 then. If we look at the first one, is that one even, odd, or neither? Nope, it's not an odd one. It's a neither one. It would be odd if it went right through 0, 0. But if I flipped it across the y-axis and then flipped it across the x-axis, it'd be down here. And so it's not odd, it's going to be neither. So when you look at the odd one, it'll always go through 0, 0. Otherwise, it won't be diagonally on there. The second one is an odd function, right? That's my cubic x cubed, my basic x cubed graph. The next one, is that one odd, even, or neither? Neither, because this is to the first, this is to the 0, and 0 counts as an even number, so that one's neither. If you weren't sure, put in 3 and negative 3, and you'll get 2 different answers altogether, and know for sure that it's neither. How about the next one? Is that one odd, even, or neither? That one's even. To the second power and to the 0 power, each count is even, so that one's even. The third one there, this first graph would be an odd function. The second one is neither. If it was going to be an even function, again, it'd have to be right at 0, 0, so that the y-axis cut it across. It's not, so it's a neither. This one here has parentheses. So if it has parentheses, you can't just go by the exponent and say, oh, it's cubed, it's got to be odd. That's one that is one of those weird cases that you actually should test. So we're going to put in a 3 and a negative 3 and see what we get. So we have x minus 3 minus 4 cubed. So if I evaluate that, negative 3 minus 4 would be negative 7, and negative 7 cubed would be cubed. Negative 7 times negative 7 times negative 7. Or negative 7 to the third power. Negative 343? Sounds right. On the second part, if I put the negative 3 in there, I'm going to have minus a negative 3 minus 4 cubed. When I do minus a negative, that makes that a positive 3. 3 minus 4 is negative 1, and negative 1 cubed is negative 1. You can see I get 2 answers that have absolutely nothing in common. This one's going to be a neither function. And the last one, even, odd, or neither? Even. Both of my exponents are even numbers. And I don't have any parentheses or weird stuff in there, so I can just look at my exponents. So I do know, I got to think of which North Dakota school it was. The one in Fargo. On their placement test for math, they ask questions about odd and even functions. So if you plan to go there, make sure you know about odd and even functions. right, the next ones will be probably really simple and fast. Talking about vertical translations to our graph. If it's going to have a vertical translation, you're either going to add a number to the end or subtract a number from the end. So if I want to translate my graph up by 3 units, all I'm going to do is add, or up by 6 units, all I'm going to do is add 6 to my equation. Then they're just going to have you simplify it, so their new equation, since negative 6 plus 6 would cancel out, is just going to be f of x equals x squared. So on number 5, if I want to translate it vertically down by 7 units, I'm going to subtract 7 units from my equation, or subtract 7. So f of x would equal what? Negative 5x squared minus 9. All there is to that. And number 6, if I can find it, I want to translate it up by 3 units, so my new equation would be 3x squared plus 5. On the next ones, we are either going to translate the graph up or down or left or right. If the number is on the end of the expression, that's going to translate it up or down. If it's a plus 2, I move it up 2. If it's a minus 2, I do it down 2. If it's in the parentheses with the x, so if I would have something like x minus 3, that's where I had to change my sign, so it actually goes in the opposite direction of what you think. This is going to move it to the right 3 places. If it was a plus sign in there, then it's going to move it to the left 3 places. So they're going to have this funky little tool that looks sort of like a finger. You're going to grab the point they have marked and you're going to translate it how it would move. In this case, this one's going to move 2 down, so you're just going to pull your whole graph down 2. I'm just going to redraw it down here. It's going to be here, and it's going to look something sort of like that. Close enough. So the minus 2 on the end just moves my graph down 2. I'm just going to take the part that's marked, pull it straight down 2, and drop it there. So if my graph is here and I want to translate it g of x minus 3, that's going to move my graph which way? To the right 3 places. So on my x-axis, it's going to move it 3 places to the right. 1, 2, 3. That's going to make that mark there, and it's going to look something sort of like that when you just pull it over 3 places. And number 9 then, if I'm going to do f of x plus 2, that's going to move my graph to the left 2 places. So I'm just going to pull it back 2, and it's going to move my graph over here. (10, 11, 12), it's going to do both translations. So this one is going to move to the left 1, down 2. So I'm just going to grab it, move it back 1 and down 2, which moves it right to here. My new vertex is at -1, -2. Like when we drew the absolute value functions. If I could draw. Art was never my strong suit. I tried to avoid that as much as possible. Still made me take art class. So on number 11, how's that one going to move?
To the right 4 and down 1.
To the right 4 and down 1. So to the right 4 and down 1 moves that over to 4, -1. And number 12 is going to go to the right 1 and up 3, exactly. So my new mark, over 1, up 3, and if I could draw, it looks something sort of like that. So you'll just grab it with the finger tool or whatever it's called, pull it over and up, and drop it where it belongs. The next ones, now they're giving you the two graphs and having you rewrite what the equation of the line, or not the line, but the graph looks like. So I'm looking here at my shift. The original graph is always going to be the one that touches at 0, 0. This happens to be the graph of x squared. It's going to move to the right 1 and down 3. To the right 1. No, to the right 2, I can't count. To the right 2 and down 3. To the right 2, down 3. So, I want to take the graph of x squared and translate it in with the x. In order to move it to the right 2, I would have to have x minus 2. That is going to be squared since my original graph was squared. Then I'm going to move it down 3, so on the end of my equation I'm going to have minus 3. I suppose I really should say k of x equals that, since that's what they tell me I'm supposed to call my new graph. So on number 14, they have your absolute value function. That one's going to move over 2 to the right and 4 down. So if I'm going to show my new graph for my absolute value function, what would that look like? K of x equals, and around the x minus 2 I would have the absolute value symbols. So the absolute value of x minus 2, that moves it 2 to the right, and then the 4 down, minus 4. And number 15, I'm doing the square root function. There's my regular square root function right at 0, 0. This one is going to move 3 to the left and up 4. So k of x would be equal to what? Square root of x plus 3. And then the plus 4 has to go on the outside of your square root. So make sure you hit the space bar so you move over and you're not under the square root when you do the plus 4. And there's my new equation.